Okay, let's unpack this. So today we're diving into something pretty deep in the weeds of industrial tech.
Mm-hmm.
The source you sent over is all about one very specific piece of kit, the Thor broadcast, F-4V8A-1D-TxRx.
Right. It's a transmitter and receiver pair.
And our mission, really, is to figure out how this hardware solves a huge problem. We're talking about moving old-school analog video and audio over, well, massive distances.
And doing it with fiber optics. This whole setup, this TxRx kit, is designed to take 4 channels of that classic composite video.
The yellow plug.
That's the one. Plus 8 channels of audio and even control data, and send it all down a single tiny strand of fiber.
So why is this even a thing? Why not just use copper wire?
Well, that's the core problem this solves. Copper just fails. If you try to run an analog video signal that's CVBS more than, say, 100 feet.
You're in trouble.
Big trouble. The signal just degrades, noise creeps in, and the picture falls apart. It's completely impractical.
So fiber is the answer.
It's the only real industrial solution. You convert that electrical signal into light, and suddenly distance is almost not a factor. This base unit we're looking at can do point-to-point up to 20 kilometers.
20 kilometers, that's across a city.
Exactly. And that's just the standard model. There are long-haul versions that can push it 220 kilometers.
Wow. And it's designed to work with all the old gear, right?
Mm-hmm. It speaks all the classic languages, NTSC, PAL, CCAM. It keeps that 1-volt signal on the BNC interface perfectly intact.
Okay, something I noticed in the specs. It's 4 video channels, but 8 audio channels. That ratio seems deliberate.
It is very deliberate. It's almost always set up so each video feed gets its own dedicated stereo audio pair.
A left and a right channel.
Yep. Perfect for monitoring or just capturing the ambient sound where the camera is.
I have to ask the obvious question then. If you're going to the trouble of running 20 kilometers of fiber, why not just use an IP encoder? Go fully digital and network-based.
That is the critical question. And the answer really comes down to 2 things: legacy support and latency.
Okay.
You have all this hardware out there, cameras, recorders, medical devices. That has to stay analog. You can't just rip and replace it. This box acts as a super high-fidelity bridge. And while the source is analog, the trip over the fiber is pristine. It's 10-bit digitally encoded video.
And 24-bit audio. That's excellent quality.
It's broadcast quality, and that's what protects the signal. You have a video bandwidth of 10 more hertz, which keeps the image sharp, and the signal to noise on the audio is better than 80 dB. You get a crystal clear picture and sound 20 kilometers away.
So it's not just about distance, it's about quality over distance.
Exactly. But there's another layer to this. It's not just a one-way street.
The data channel.
The data channel. That reversed RS-485 interface is what makes this functional for, say, remote surveillance.
So you can send commands back to the camera.
Precisely. The operator at the monitor can send commands all the way back up the fiber. Pan, tilt, zoom, a PTZ camera, for instance.
So it's a complete control loop.
A necessary one. And for some really niche broadcast stuff, it even supports things like tri-level sync pulses.
That's for timing, right? Like a black burst signal.
Yeah, to keep all the equipment in a broadcast chain perfectly synchronized. And the unit itself is, it's built like a tank. It'll work from a freezing -20°C all the way up to a scorching 75°C.
So if we boil this all down, what are we looking at?
It's an industrial strength bridge.
Right. It takes these old, reliable analog signals, turns them into light, and makes sure they arrive perfectly and can be controlled across insane distances where copper just wouldn't work.
That's it in a nutshell.
The source points out that so many critical systems still rely on these analog interfaces. And it makes you think, in a world totally obsessed with IP and Ethernet everything, where else are these specialized kind of invisible fiber solutions quietly keeping our infrastructure running? It makes you wonder how many other legacy systems are out there, communicating perfectly across vast distances thanks to little boxes like this. Something to mull over.